In this video, we are going to continue the discussion on functions. So I have a quick example at the top here. You can see we have the return type. In the previous video, that was void. Now the return type is the value type that the function will return, and that can be int, float, and so on. And we use void if none. So if you don't want to return something specific, again like we did in the previous video. There's a good explanation of the void type on the Microsoft documentation. It states, the void type describes an empty set of values. No variable of type void can be specified. It is used primarily to declare functions that return no values. So we typically create variables of type int or float, and so on, but not of type void. Then we also have a function name, and this is the name that we will use when we call or invoke the function. Now, rules for legal function names are the same as for variables, as I mentioned in the previous video. So just a quick summary on these things. Of course, you also want to give it a meaningful name, so relating to what the function will actually do. Will it add two values together? Will it print something out to the screen? Like, what is it going to do when you call or invoke that function? Next, we have the parameter list. This will determine the legal arguments that we can pass to the function when we call or invoke it. If there are no parameters, then the parentheses are left empty, and then in other words, we don't pass any arguments when we call that function. If there are multiple parameters, then they are separated by commas. So in the previous example, in the previous video, we did not have any parameters. So parameters are basically variables. So variable declaration, so int myInt or int temp or something like that, some float maybe, or a string, and you separate those out with a comma, so you can have multiple parameters. We'll look at another example here shortly. Then you have the return value, and that is the value, which again is a variable or some expression that is returned to the caller. This value should be of the same type as the function return type. Alright, that's another important thing. The return keyword will terminate the function, and you can have multiple return statements per function. This is typically an if-else statement, so if this happens, then return this one value, otherwise return some other value. So quick demonstration before we move on to Visual Studio. You can see I have int function name, so the return type in this case is integer, so the calling function, in this case main, will expect an integer back from this function. So int function name, and then between the parentheses we have those two parameters. Both of them are integers. One can be an integer, another one can be a string or a float or a character or something else. So you can see in the return statement I'm adding those two parameters together, and I'm simply returning that to the caller. I have a comment here in the main function that says main is the calling function, and you can call or invoke the function in various different places. So in this example, I'm simply printing whatever that function returns out to the console. You can see cout, and then I call that function. So in this case, it'll print out 5 to the console. You can see we have these two literals, so 2, 3. And the order here is very important as well. So if that second parameter was a float or a string, then you want to make sure that you pass it the correct thing. So in this case, this is simple because we only have two integers. I have two integer literals here. They could be variables as well, so as long as they match the parameters. But the main difference here is that these are called arguments. So where you actually call or invoke the function, you will give that function arguments. So in this case, 2 and 3, those are arguments, and those will be the input to the function. So the parameters will basically receive those arguments. So it's like you ask your sister to calculate 9 times 7, for example. So one argument will be 9, and another one will be 7, and then she'll do that computation. Alright, and then she'll return the result of that computation back to you. So again, where you call or invoke the function, you'll give it arguments. Okay, those comma-separated arguments. But the actual declaration of the function between parentheses, those are called parameters. So it's just these differences that we have to get used to, and we'll keep adding a few things as we go along. In fact, in module 102, we have a lot more to talk about when it comes to functions. Okay, here is a quick example program. So I basically went ahead and I changed the function name. So add two integers, that's basically what it does. We feed it two integers, it will add those together and return the result. Okay, as you can see in main, so basically just print the result of that computation out to the console. So up here we have the function. Again, this is outside of main. And in the previous video, this was void. But in this case, we want to return a value back to the caller. So this can be int, it can be float, and so on. Basically what happens is these parameters will receive arguments. So this parameter 1, for example, this is the declaration, but it will be initialized to whatever we pass in this, this first argument. Then we have the comma operator, we pass another argument, so in this case 3. The second parameter will then receive that argument. You can think of this as a variable declaration, and it is initialized to the argument that it receives. So in this case 3. You can think of these variables as being local to the function. We talked about scope quite a bit at this point, but when it comes to functions, these are local to the function. So similar to a while loop or a block variable, you can think of these as block variables in that they are accessible within the function, but not outside of the function. So similar to a for loop, so let's say int I is equal to 0, that I variable is accessible within that for loop, but not outside of it unless you declare that a variable outside of that code block. So in this case, we can do global variables. So we can actually declare this variable outside of this function in the, right at the top here, global to everything. And then that variable will be accessible inside of this function, but also in main and whatever other functions we might have and whatever other code blocks we might have. Now we will talk about that in an upcoming video, right? But the point is these variables are local to this code block. So if I try and access in main now, if I try and access one of these parameters, that won't work, we'll get an error. I'll do something like parameter 1 plus equals 3. So I want to add 3 to that, and you'll see we get errors. And the problem here is that, again, this is local. This parameter 1 variable is local to the add two integers function, this code block. So it will not work in main, it's not accessible in main. If I go and cut and paste that into the add two integers function, so in the code block, in the body of that function, build and run that, and you can see this works fine. Okay, so that was a quick introduction to functions. We'll do a few more examples coming up. But just as a recap, you have the function right here. You call or invoke the function and you pass the arguments into there. Again, also comma separated, just like the parameter list. They have to be the same type as the parameter list. So if it was a string, the second parameter was a string, then the second argument then also needs to be a string. In the function itself, those parameters are variables that we declare, and we initialize them to the arguments that we receive. So they are temporary in that each time you execute this function, these will be created. These are variables that will be created. So in other words, memory will be set aside for those variables. And then once the function is finished executing, so this closing curly bracket is reached, those local parameters or variables will be destroyed. Okay, just like we talked about before with code blocks or compound statements. Okay, the same stuff applies here. There is more to this, so you can have references where that local parameter references whatever it is that you pass it instead of copying it. That is more efficient, for your memory usage. But we'll discuss that in module 102 once we've talked about pointers and references. Okay, here is another example. So this program demonstrates what the ABS function does. I have an integer here, temporary integer, and then I do cout, please enter an integer. So I enter that integer, okay, store that in temp. And then in this second output here, I do abs, an abs function, and I pass that temp. So this will give us the absolute value of that. What does this mean? I'll go and run this. Let's say we do 50. We'll get 50 back. But if we do minus some value, so you'll get the positive back, okay? So that is useful if you are not concerned with a negative value such as minus 50. And that's useful in some cases. So let's say you do, so let's say you have an error of 5, you are off by 5 units. Let's say you do a guessing game and you want to know like how far you were away from the correct answer. So you don't want minus 7 units, right? You want, okay, I was 7 off from the correct guess, or whatever the error might be. And that could go in any direction. It could be positive or negative, but the point is you are 7 units, away from the correct answer, for example. I don't use this that much, but it is useful. And it's just a quick function to demonstrate. You can see that I did not write this function. This is functionality provided to us from the standard library. I'm just using it. The point is we can also use functions that were provided to us either from the standard library or from third-party libraries. There are used libraries such as Qt, for example, or game engines such as Unreal Engine, and so on. The standard library is of course what we are using here. You can write your own version of this. It's not that difficult, but I leave that as an exercise for you to try and do. The main takeaway here is that we don't have to write all of the functions ourselves. If we know that the standard library or some other library already contains that function, then it might be best to use what we already have available, because in that way you don't reinvent the wheel. And these functions are tested as well, rigorously tested, so they are reliable. Whereas the functions that we write, you might have to test them, many times to make sure that they are solid and reliable. Especially complex functions. The abs function again is not that complex, but your functions can get quite complex. Alright, I'd also like to note here that let's say I do another integer. You can see that I create a new variable called temp_abs for lack of thinking about a better variable name at this point. And so I enter that integer and then I store the absolute value of that into this temp_abs variable, and then I print it out. So you can say I call that function over here. This is the temp is the argument. You'll see we get the same results here. If I do minus 50, we get 50 back. If I do 50, again we get 50 back. But the point here is you can initialize variables or set variables using functions. And this returns a value. This could be 3, right? Because it's going to be returning some value. And only once that function is executed and returns a value, then that value will get assigned to the variable, similar to, I'll just undo a couple of times, so similar to here where we do it in the output. It will pass that function the argument, so it will call or invoke the function, it will calculate and return, so that function, the body of that function will execute, the function will terminate and return a value. The section here will be replaced with whatever that function returns, and then we simply print that out as well alongside the rest of the stuff. Okay, so I hope that makes sense. Again, you can run this. Works fine. So just a couple of examples of functions. So I keep using them in the output here, but as we've seen, you can use them to initialize variables, and pretty much anywhere you want to use a value, you can, as they return a value, then you can use a function instead. So what have we learned about functions? Just a summary here. We can use functions from the standard library or from third-party libraries. These are tested, so they are reliable, right? So we can use them without worrying about it too much. Instead of, implementing some functionality ourselves, it might be best to use functions from either the standard library or from third parties, because those will be tested. Also, to reuse code, we encapsulate it. This means we put the code in a named self-contained block of code, or in other words into a capsule, right, that is easily used or digested. And the process of encapsulating the code is called refactoring. So let's say you have a couple of lines of code, so a few statements that you see in your program that you're using that over and over again, and you want to kind of put that into a function. So you encapsulate those statements into a function that is then reusable. A function should be usable as a black box, so where the program is not concerned with how the function is implemented, or in other words, how the function works behind the scenes. Now, how the function works should be evident from its name, the parameter list, and accompanying comments. The process of hiding implementation details to reduce complexity and increase efficiency by again creating reusable code by functions, for example, and we'll look at a few more options in Module 1 or 2. But this process of hiding the implementation details is known as abstraction, right? You encapsulate stuff and you think about high level, so the idea what it is that you actually want to build, you build that out, and then the programmers that actually use it, they can just use it by again looking at the parameter list, accompanying comments, and then using that in their code without having to worry about what's going on behind the scenes. Again, this idea of abstraction. Now we'll talk about abstraction in more detail in Module 1 or 2. This relates more to classes than it does functions really, but still the basic idea applies.